When people talk about modern naval warfare, the spotlight usually falls on aircraft carriers, submarines, and drones. But beneath the surface, a quieter and far more disruptive technology is reshaping the balance of power at sea: naval mines. Today, we're going beyond drones to examine Iran's latest breakthrough: autonomous naval mine warfare. This isn't about massive fleets or high-profile weapons. It's about smart, unmanned systems designed to deny access, slow down superior navies, and reshape maritime control using asymmetric means. So how is Iran using autonomous mine laying to change the rules of naval conflict? Let's break it down. Naval mines may seem old-fashioned, but they remain one of the most cost-effective weapons in maritime warfare. Historically, mines have damaged or sunk more ships than submarines in many conflicts, forced navies to slow operations and reroute shipping, and created long-term psychological pressure. The difference today is automation and autonomy. Instead of relying on manned vessels or aircraft to deploy mines, Iran is exploring unmanned and semi-autonomous systems that can operate quietly, unpredictably, and at scale. Iran's naval strategy has never been about matching global powers ship for ship. Instead, it focuses on area denial, disruption of maritime traffic, and exploiting narrow waterways, like the Strait of Hormuz. Autonomous mine warfare fits perfectly into this doctrine. Mines don't need air superiority, satellite coverage, or constant communication. Once deployed, they become persistent threats, forcing adversaries to invest time, resources, and specialized equipment just to move safely. Traditional naval mines are simple: contact triggers or magnetic sensors. Iran's newer concepts go much further. Analysts believe Iran is developing smart naval mines that may include acoustic sensors to identify specific ship signatures, pressure and magnetic sensors to reduce false triggers, timers or remote activation logic. These features allow mines to ignore civilian traffic, target specific classes of vessels, and remain dormant until conditions are optimal. This dramatically increases effectiveness while reducing unintended consequences. The real breakthrough isn't just the mines, it's how they're deployed. Iran has showcased and tested unmanned surface vessels, USVs, autonomous underwater vehicles, AUVs, and modified fast boats with minimal crew. These platforms can quietly lay mines without exposing pilots or sailors to immediate risk. Autonomous deployment also makes detection harder, since there's no obvious manned launch platform to track or intercept. In narrow maritime corridors, even a small number of such systems can create outsized strategic effects. Autonomous mine warfare offers several key advantages. First, deniability. Mines can be difficult to attribute immediately, complicating political and military responses. Second, persistence. Once laid, mines remain active long after deployment, forcing constant vigilance. Third, cost efficiency. Clearing mines often costs far more than laying them, especially when autonomous systems are involved. For Iran, this flips the economic equation of naval warfare. The strategic implications extend far beyond Iran's coastline. Key shipping lanes, especially in the Persian Gulf, are narrow and heavily trafficked. Even the perception of autonomous mine deployment can increase insurance costs, slow commercial shipping, and trigger multinational mine countermeasure operations. For conventional navies, this means investing heavily in mine detection, unmanned clearance systems, and escort operations diverting resources from other missions. Iran's focus on autonomous naval mines shows that future maritime conflict won't be defined solely by drones or missiles. Instead, it will hinge on who controls access, who can deny movement, and who can impose costs without direct confrontation. Autonomous mine warfare represents a subtle but powerful evolution, one that challenges traditional naval dominance without ever firing a shot.